And in the last video on equations, we looked at what an equation was. We realized that it was something we'd actually been dealing with for most of our life in our mathematical education. And we learned how to solve some basic equations. In this video, we will just extend ourselves a little bit to solve, as you might describe them as two-stage equations. Let's look at an example. Let's take this. Let's think of a number, call it x. Multiply it by 3, so 3x, and add 5. And our answer is 26. And the question is, what number did we start with? Or to put in other words, let's solve this equation for x. Let's find out what x is worth. Okay, so 3 lots of x plus 5 equals 26. I want to end up with x equals something. We talked about the fact that our equation is like a set of scales that has to balance. So anything we do to one side of the equation, we have to do to the other side too to keep the scales balanced. So let's get rid of that picture. It's going to get in our way. If we've got 3x plus 5 and we want to end up with just x, let's get rid of the plus 5 first of all, just to leave ourselves with the x's. How do we get rid of 5? Well, we take 5 away, right? So take 5 away from the left. If we take 5 away from the left-hand side, we take 5 away from the right-hand side. So on the left-hand side, we have 3x left. And on the right-hand side, we have 26 minus 5, which is 21. Okay, so 3 lots of x equal 21. I want to know what 1 lot of x is worth. So if I divide my 3x by 3, that will tell me what 1 lot of x is. And if I divide the left-hand side by 3, I must do the same thing on the other side. 3 divided by 3 over here is 1, so that leaves us with 1x, or x. And 21 divided by 3 is 7. So we think x is 7. Let's check that by substituting in our value of x here. So 3 times x, if x is 7, then 3 times x here will be 21. And 21 plus the 5 that we have here does indeed, of course, equal 26, which confirms that x really is 7. Let's work another example, perhaps where x maybe isn't necessarily a positive value. I think of a number, I times it by 5. I add 4. And my answer is, well, let's say our answer is 9. There it is. Okay. Is that a good example? No, that's a bad example, actually. Let's say our answer, here we'll add 14. And our answer is 4. There we go. Okay, so 5x plus 14 equals 4. We want to just end up with an equation that says x equals something, so we need to get rid of everything else on the x's side. So let's get rid of that plus 14 first of all by taking it away. Take away 14. Take away 14 from the other side to keep these scales balanced. So 5x on the left and 4 minus 14 on the right. 4 take away 14 is negative 10 or minus 10. 5 times x is minus 10, so we'll divide this by 5 to leave us with 1 lot of x. And over on the right-hand side, I don't know to write it out as a fraction like this, minus 10 over 5. But if you remember your work with negative numbers, when you divide a negative number and a positive number, your answer is negative, your quotient is negative. So minus 10 divided by 5 will be a negative answer, and 10 divided by 5 is 2, because 2 5s make 10. So x equals minus 2. Is that correct? Let's check it up here. 5 times minus 2 equals minus 10. And minus 10 plus 14 is indeed 4. So we're right again. Wow, would you believe it? X doesn't necessarily have to be on the left-hand side, it can be on the right-hand side, and x doesn't necessarily have to be a whole number either. Let's think of a number. We'll call it x again, because I'm desperately unoriginal. We'll times it by 7, we'll add 3, and our answer is, let's say, 13. There we go. So 13 equals 7x plus 3. We'll take away that 3. You know what, actually, let's be a bit original here, shall we? Let's take away 3 from our 7 lots of x. How do we get rid of minus 3? We get rid of minus 3 by adding 3, right? Because they cancel out. Minus 3 plus 3 is 0, yeah? If we add 3 on the right-hand side, we have to do it on the other side to keep the scales balanced. So we've got 16 on the left and 7 lots of x on the right. I'll take the 7 lots of x and divide it by 7 to find what 1 lot of x is. 7 divided by 7 is 1, right? And on the right-hand side, do the same thing. Write it as a top of your fraction like that, and it'll help you find the answer. How many 7s go into 16? 2. Remainder 2, because 2 7 to 14.
So we've got 2 remainder. We write that as a remainder over the number we're dividing by, which is 7. So x is 2 and 2/7. This very simple video shows you how to deal with multiples of x and situations where you have multiples of x and you're adding and subtracting an amount from those. X does not have to be a whole number, it can be a mixed number like so. Don't bother changing it to a decimal, by the way, there's no need, just leave it as a mixed number, it's not a problem. X doesn't have to be on the left hand side, it can be on the right hand side as it is here. Just fairly simple. All you're looking to do is isolate x. Isolate the x's on one side and get everything else onto the other side, and once you've done that, you divide down until you've got one lot of x, whatever that equals. That's your solution.